Given that the integral from -2 to 2 of f of x dx is nothing, and the integral from 0 to 2 of f of x dx is 6, use the properties of definite integrals to find the integral of 0 to -2 of f of x. Well, this is going to be fairly nice, okay? But let's try to draw ourselves a picture. What do we know? Well, from 0 to 2, I have some area that is 6, okay? So that's from 0 to 2. Everything starts out here at -2. All right, so all of this is going to add up to 0 when I figure that out. And that's almost too much common sense, but let's just go a little bit further. The integral from -2 to 2 is going to be the same thing, and I'm just using very lazy notation. I'm going from -2 to 2, so it makes sense that -2 to 0 plus 0 to 2 is going to give me -2 to 2. -2 to 2 is nothing. Okay? -2 to 0 is, I don't know. But I do know that 0 to 2 is 6. So if I subtract 6 from both sides and clean up the way this is supposed to be worded, all right, you're gone. I can say the integral from -2 to 0 is of, what is this, f of x dx is going to equal 0 minus 6, which is -6. Circling my answer would be wrong. Why? Well, because it's not giving us that. The limits are flip-flopped. Oh, so if I have flip-flopped limits, it's a simple fix. Flip-flop the limits like we have up here, and then while you're at it, just take the opposite of the area. So -6 is +6. Tricky, tricky. Tricky, tricky, tricky. So I think many people wouldn't really think about it and say the answer is -6. But that's because the integral and its limits are in the correct order. We were given it out of order. We were given to us backwards, which means our answer is going to be opposite. Gotcha.